So thanks everybody for coming. Welcome. I'll probably go a little bit further. Welcome. My name is Martin Grebač. I'm a software engineering manager responsible for project Metro, which includes JAX-B and JAX-WS technologies. And together with me is Chen, who is the technical lead for web services. We are both from Oracle, actually. So in this talk, as you kind of expect, is going to talk about what the plans or thinking is with respect to JAX-WS .Next. I mean, JAX-WS review of the JAX-WS specification. Before we go any further with that, I again mentioned this most famous slide from Java 1 and Oracle Open World. If we talk of any dates or any future plans, they cannot be incorporated into any contract, and so please don't believe us that much. This can be changed anytime. So the formalities behind us. So we divided the areas we wanted to talk about into two items, most likely. So one is kind of little bigger features which we want to add to the JAX-WS specification, and the other area is these small details which are kind of, but on the other hand, small details, but very important to make sure that whatever you develop is a portable application. So these are areas where JAX-WS either didn't specify anything or was a gray area to where things weren't too much clear. So going first through the features. The most common one, on at least that what we see on the Metro forum or JAX-WS forum, that's bean validation. I mean, we mentioned it here, even though it more or less belongs to JAX-B. But let's first just get us on the same page for what bean validation is. So it's basically implemented as implementation of JSR 309. So, I mean, there's the spec which defines the bean validation, and it allows you to specify a set of constraints on your objects, either through specifying or either through using the constraints which are already present in the bean validation specification, or I mean, such as those you see on the slide, the size, for example, or you can define your own constraints such as, I don't know, phone number or something else, some ID for your database and stuff like that. Go ahead. Okay. So let me switch to my next slide. Yeah, so this is like two ways. When you are writing your Java classes and it has, for example, the add not null annotation, you are able to, you should be able to get this preserved in the schema, and thus in the WSDL. So in this case, it should be nillable equals false. The default is nillable true. And also the other way around, there are several particles in the schema or constraints which can be preserved during the schema compilation in your code, such as you see there, when you want to specify multi-occurrence of some elements, then this can be represented by the size annotation. So that's the idea. That's the main idea behind bean validation. And it's supporting the JAX-B and JAX-WS. Not sure. I'm kind of a bit hard to hear. But yeah. So I mean, this just adds another set of constraints. So right now, JAX-B doesn't handle, for example, the even if you do the schema validation, JAX-B, well, let's say this way. So JAX-B right now doesn't preserve the things in the code. So you have to do the schema validation, but that's not necessarily what you want, and that's not necessarily, you don't see the constraints in your code, so you don't know that this is kind of what is expected in your code. I mean, what is kind of expected from this item. So that's where this kind of helps. So you see it in the Java code, what the constraints in the schema are. And of course, if you do the schema validation, that's like the full-fledged. I mean, you cannot do anything more than that. Right. So yeah. So that's a good question, but I don't want to get like into answering this because this is like a topic for more or less like discussion, an open item. This is not something that's already in the spec. I mean, these are just things that we want to discuss and bring into the spec. But what the actual result of the discussion will be, so that's something I'd like to leave open. In this case, so that's why I don't want to get into big details on this. You mean like pluggable? I'll get a little bit into that, but yeah, I'll mention it when we get to some kind of pluggability layer. Okay? Okay, so going further from the bean validation, yeah, bean validation turned out to be really the famous one. There's a couple of there's a couple of WS star technologies that made it to the JAX-WS spec, so like addressing or MTOM, and we think there's a place for some additional technologies to get in there. Specifically, one which we would like to mention is reliable messaging. So let's say, for example, you would be able to specify these quality of service attributes on your web service through, let's say, through the annotations at most ones, exactly ones, at least ones, which are kind of mutually exclusive. So that's kind of that would be an addition to the JAX-WS spec, adding the additional constraint or additional quality of service which RM provides, the in order. That's kind of requires a little bit more thinking and may require a little bit more support of the programming model so that you are able to work with the session that is required in this case on the RM side. So the other technology, or basically, when we think SOAP, it's usually goes down to security. So security is one of the most important areas for SOAP, I would say these days, and that's the reason why we think that it belongs to JAX-WS specification, and to make sure that you are able to implement portable, secure web services. So, as you probably are mostly aware, the security configuration is kind of huge. Usually it goes down to like big policy files, so you cannot expect or or I think we cannot expect that there will be a simple security annotation which would just make things work just like that. So there would most likely be or the reference to some kind of policy, policy expressions and definition of the security for the JAX-WS web services. And that goes down a little bit to connecting the JAX-WS specification with also another WS star spec, which is the policy. The other potential way, how to solve security in the web service space, or something that we've been thinking about, is the JSR-196 pluggable way. However, if we want to add additional, so this is a little bit issues if we would like to add additional programming models to JAX-WS, then JSR-196 does not expect that, or is not built to support that, so such as the async support. So it's not prepared for this case. So the additional thing which we are thinking about is Jigsaw. We actually, we started thing when it was planned for JDK 8, but now it's moved to JDK 9, so there's a little more time for this. So there's several aspects to look into this, and the first one is currently the service loading mechanism for, class loading mechanism in JAX-WS does not count with Jigsaw and modularity, so that's one thing that needs to be improved or specified. And so this affects the way the factories are loaded and the way the providers, the runtime is being looked up. So the most likely solution for this is to use the JDK default service loader and keep the current implementation for backwards compatibility, because the JDK service loader is going to be Jigsaw friendly, so that should basically work in both non-modular and modular JDKs. But of course, Jigsaw specification is still not done yet, so things may change in this area as well. So the other aspect to look into this is and we already started to think, look into this, is to modularize JAX-WS and JAX-B itself. So the expectation or the current plan is to, in the JDK, to modularize the things that go into JDK through JAX-WS by definition, by specification. So JAX-WS, JAX-B, Sage. And let me see, just one more. We'll get their own modules, and with potential to be so that they are pluggable in a better way, so that there's a possibility to replace the module implementation underneath. So that goes a little bit to the pluggability question that has been asked before. So this, hopefully, Jigsaw will finally come in the JDK 9, and it will end the endorsed mess which mostly JAX-B and JAX-WS users are living through. So yeah, that was mostly the server side, or in general features. Going through the client side, so there are several use cases which would need some help from the spec. First one is the provider selector feature, where on the client side you need to have a let's say more exact way how to specify which provider is going to be used on the client side. Sorry, what? So the runtime. Let's say you have multiple runtimes on the client side, so you should be able to make sure that you pick up the right implementations on the client side as well. So that's kind of a small thing. And so the additional thing is WSDL connection config, which is missing on the client side. Sorry, this is especially useful when the WSDL is hidden behind, like, let's say, secured by a password or SSL, so that you are able to specify this connection config in a portable way. Of course, we're talking about JAX-WS spec, and be able to retrieve the WSDL when it's required. Currently, this is like solvable, so there's a workaround that you basically download the WSDL and use it through the catalog file, and basically this way to specify it for the client. So the other issue which goes down to the, let's say, the web service ref, for example, annotation is the thread safety and injection. So in, let's say you have a servlet and you specify the web service ref annotation, and so that way you are injecting port instance which is kind of let's say unspecified in JAX-WS, whether it's thread safe or not. So it's not thread safe, and you need to basically use the synchronization to make sure that your code runs properly. So this is kind of thing that needs to be clarified in specification and potentially improved. And the last thing from the client side is the binding it's the closable, where for multiple technologies, or I mean just for JAX-WS by itself, it's useful to make sure the binding provider implements closable so that you are able to free the resources. This is kind of useful for, especially when the some of the WS star technologies are used underneath, like the reliable messaging or I don't know, some other stuff which use more resources than the regular JAX-WS web service. So there are two ways how to potentially. Oh, go ahead.
Well, I just wanted to go back to the port injection. Isn't that easily solvable with thread load? That's sort of the way I've got it. I mean, now.
Yeah. So the documentation to the web service ref annotation use the well-known, or I don't have the exact words, but well-known synchronization techniques to solve this. But we think that it's not, I mean, it should be handled in a more simple way. JAX-WS is part of the Java EE specification, and that expects that the coding should be simpler and easier, and the learning curve and everything should be not that steep as usual. So this is kind of the aim for this. So anything to add?
Yes, the implementation, I mean, like a different container implementation is allowed to use Straddle code to solve this problem. But the issue we want to emphasize is that when you are using the port injection on the spec level, it doesn't guarantee the proxy you inject is thread safe. So very often you will use such a injection, for example, on Servlet. Servlet is supposed to be thread safe, that you can have multiple concurrent access. But the port proxy itself is not.
Okay. So, yeah, that brings us to the, let's say, a couple of times already discussed topic, server-side async in the JAX-WS. And there are several ways how to look into this. So one could say that it's basically, it's there through non-anonymous addressing, where basically the container is expected to send a response right away, and then serve the response to the addressed endpoint. So this is not the full async that would solve the problem of long-running async operations. So the other solution to this is to provide some kind of response dispatch interface, which is then able to be used for sending the response. And I think this was maybe even like presented a couple of times. So I'm not quite going to deep dive into this one. The other potential way to solve it is to use something that you see in the .NET, which is a bidirection service endpoint interface, or a bidirection SEI with callback interface. And so this, let me just skip to the other slide. I mean, this is more or less how it looks like. So these are basically one-way operations, and the SEI implements one side and specifies the callback interface for the other side. And then this is used for getting the async value back. The trouble little with this approach is that you need to somehow maintain the state in some cases here, and that brings us to the other topics which Chen is going to continue on, such as stateful web services.
So I will continue to talk about some new feature and also some spec fix we want to do. So the first thing, stateful conversation. I think it has been a debate that a web service should be stateless or stateful. But regardless of this debate, if we want to make web service stateful, what kind of API we can introduce? Currently, there are two similar API already in Java EE that we can look at to learn something from their experience. And the first one is like a stable section bin. And the second is the servlet HTTP section. The difference between these two models is that the stable EJB itself is it represents the client state. That the EJB itself is the life cycle of the conversation. The servlet is a little bit different. A servlet, it has a session bag that allows you to store states in that session bag. So the servlet instance itself doesn't represent any client-specific state. So these are kind of two different things we can borrow from previous experience, and then we can use those to produce something similar in JAX-WS. But for the HTTP section, actually in JAX-WS, it's already supported. But like you can use the web service context injection. And from the web service context injection, you get the message context, and then you get the HTTP request. From there, you get the HTTP section. It looks like the code looks long and a little bit hacky. And that is the first problem of this programming model. The second is that because it's the HTTP section, if you understand how the container works a little bit, you know this is going to be implemented by using HTTP protocol. Means that for each conversation, or let's say section, you usually have an identifier to identify this section. And HTTP implement the session identifier, for example, on cookie, which is the HTTP protocol. And the reason you want to use web service is that you probably want to have the session identifier to be carried on the soap header. But this is not. This is HTTP. So we are thinking about the last one is that instead of using the long get to get the HTTP section, we directly support a session back directly from the web service context. And also, we will also implement it by using, for example, a web service protocol like WS addressing. So we were using the WS addressing to carry the session identifier. So this is one of the choices we currently have to support stateful conversation. And the other choice we have that is already implemented in R is this programming model. So this programming model is a little bit complicated in that not only define your original service that to be stateful, but you also need to define a kind of like a instance manager to provide the session identifier, to provide the instance identifier of that object. So for this case, the book itself is the stateful object that it has some state you want to maintain across different multiple requests. That is the review. You want to add review, and then you get a list of review. And the book store on the right-hand side is the instance manager I was talking about. The purpose of it is so that you can start this conversation, and then it provides an identifier for that specific state object. So the code looks a little bit complicated, but the reason is that the good thing of this over the previous one is this programming model allows you to explicitly start a conversation and end a conversation. If you ever use the HTTP session, you know, on the client side, it doesn't kind of have an explicit way that I want to start it and I want to end it. Usually it's ended by session timeout. So this allows you to more explicitly start it and end it because it has a manager of that. Please.
I'm just curious with what's coming out in the new Java specifications. Why wouldn't we try to harness closures to be able to do some of this stuff rather than, you know, having to programmatically declare classes and things, but to be able to define a closure that would pass into these things on the annotation? Or
Yes, I think that would be a good, at least on this example code, one thing I think we can remove is the last line, the stateful web service manager. That line probably can be removed. But as I say, the purpose of this programming model actually is to have two web services, one as a manager, one as an instance. So if we remove it, it's kind of go against the purpose. It's kind of like in the EJB area, we have the debate of we need the EJB home or not. It's kind of similar. We want the explicit management on the state. And the next feature I want to talk about is using raw XML in your service endpoint implementation. It's kind of, because web service is for XML, so it's quite common you want to use, directly use, like, for example, DOM element or Sage SOAP element in your web service implementation. And the purpose is that this object allows you to do some XML-centric operation like SPass or SLLT to read the information from within the XML. And we already have this feature since JAX RPC. And in JAX-WS, we have the provider interface that you can implement so that you can have the request and response in raw XML. But there are two issues of the provider. First, when you use provider, it's all XML. What I mean is that what if I want the request to be XML, but the response, I want to construct it using the JSP object. This is actually very reasonable because JSP object is much easier to construct than using the DOM element. I think you understand what I mean. But on the request side, you want to use, for example, SPass to read the XML info set. And that is the first issue. So, and the second issue is that provider only have one method to implement. It's called invoke. But it's very common your web service will have multiple operations. For example, you want to add user and remove user. It's two operations. But provider only have one method. It's called invoke. And when the SOAP request go into your provider and you want to do the operation dispatch, the logic of operation dispatch is actually not that straightforward. You need to consider several things like WS tracing header and HTTP SOAP action header, and also the payload signature is actually, I would rather leave it to the JAX-WS runtime to do that. And that's why we come up with another idea of that you implement the web service as you did before, like the SCI style, but it allows you to use DOM element and sage element, and also other potential XML type in your SEI, so that you can do both. You can have the strong type parameter and return type, and also XML parameter and return type. And next, I'm going to talk about some probably bug fix or clarification of the current spec. A large amount of existing issues we have are on data binding, and I think that is also because current spec cover, there are a lot of the content on data binding, and the most typical one are around the array and collection. And the collection here, I'm specifically talking about java.util.list. If you want to use other collection type on web services, it's actually not so supported. So take this example that you kind of echo array. Most important thing to know is that this is only supported, officially supported, I would say, in the format of dark literal wrapped. If you want to use RPC literal or so-called dark lit bare, you are going to go into some problem because from the spec side, there are a lot of issues to support that. And the second, besides the dark lit wrap, the other issue is that the second item, the 483, if you want to use now, because a collection reference or array reference, you can assign it a now, or an empty collection or empty array, or an array containing only one item that is now. It's difficult to express these three differences when you deserialize or when you serialize to XML. That is why we want to mention this. If the now value or the empty value is very important in your application logic, you have to be aware. This has been an issue. And the other similar type that have similar issue that you have to use in dark literal wrap is java.util.map. And as I already mentioned, if you want to use those type, you better use darkly wrapped. But we already try to implement others, including the support for other collection type in the RI as a kind of experimental feature. But it only supported when you are using the top-link JSP implementation or X-link JSP implementation. So current RI allow you to choose at least 3. Actually, it's already 3. Different data binding. One is the default, that is the JSP RI. Second is the X-link JSP. Third is the SDO. And I think one of you mentioned the thing like the caster or even XML bin. Those potentially could be implemented by using different plugins. And there are other more data binding issues, but they are all around using different type on darkly wrapped. And the most important thing is that those types can only be used in darkly wrapped. And a general issue we encounter is that we heard the request that want to generate XML document and on the whistle and schema from JavaDoc. The issue for this feature is that JavaDoc is only preserved in the source. It doesn't preserve in the bytecode. But most of the time you do Java to whistle. The whistle and schema is generated from bytecode. And that's how difficult this is to implement. And the second thing, we already discussed a little bit in the BIM validation. That is to support schema validation. And when we support the BIM validation, it's not intended to replace the schema validation. What I mean is that if we want to introduce the schema validation, it should be cover more schema validation, the schema constraint feature other than BIM, because there could be some schema constraint that cannot be translated to BB constraint. But an important issue on schema validation to know is that schema validation is a very expensive operation because you need to load the whole schema, and also you also need to load the whole XML in the memory in order to do the process. So that is the most important issue, I would say. But I know some of the security things require schema validation. That is why I think the schema validation probably is already implemented in most of the proprietary implementation. And the last issue is the support for SOAP 1.2. SOAP 1.2 is already officially supported in JAX-WS, but important issue we have encountered is that because now we have SOAP 1.1 and SOAP 1.2, what if I want to have both SOAP 1.1 and SOAP 1.2 on the same whistle generated from the same implementation? Unfortunately, current JAX-WS doesn't clarify that. And I don't think it has been implemented in any of the Java implementation, but it already exists in .NET. So you can say this is something on the Java side we probably can catch up. And client-side thread safe, I think we already discussed that previously. And the most important thing is that client object is, on the performance-wise, is very expensive to create. And the reason it's expensive to create is that you need to read the whistle. And that is something, as a programmer, you probably need to be aware of. So to work around it, we already suggest that you can use a local file and use the XML catalog, redirect to the local file. And hopefully this is the best one. The holders, the problem of holder is not only cosmetic. We would suggest not to use holder from Java to Whistle. When you are coding your web service from Java to Whistle, you should try to avoid holder. And the problem is not only cosmetic, but also functional. Because holder assume pass by reference when the JAX-WS runtime call your endpoint implementation. But if your endpoint implementation, for example, is deployed as an EJB, it could be kind of remote to the JAX-WS runtime, and the holder is not going to work. So, but this is kind of an edge case that not so many people encounter it, but it's a spec problem that we should not suggest using holder. And the handler, the enhancement around the handler we have been thinking about is that currently handler or handler chain is attached to an endpoint. What I mean is that endpoint and handler chain is one-to-one. But what if I want to have a global handler chain or application level handler chain that executed for all the web service within this application? And the other feature we have been thinking about is like, for example, operation level handler chain, because that can be used to process some explicit SOAP header. And for the global and application level handler chain, it can be worked around by sure the handler configuration. That should be all we want to talk. I run a little bit fast because they are too much. So, yep. Please. Okay, JAX-WS on the spec level, it does not say something about pluggable. I would say it tightly coupled with JSP spec in the spec level. But in the implementation level, JAX-WS, we already provide SPI that you can implement. But implement that SPI is very complicated. So I would suggest another way. Another way is JSP actually allow you to do some sort of like a custom serializer or deserializer. That probably is something you can look at. It's called XML adapter. But it's actually not adapting XML to a Java object that you are looking for, but it adapts a bin to a Java object you are looking for. So that may cover some of the use case. But if it's not, then you probably want to look at the SPI implementation. But it's fairly complicated.
Besides the spec talk, the JAX-WS RI already provides the functionality to replace JAX-BE RI with Moxie. Yes.
I
Yep.
have to ask a question about performance. In JAX-WS 2.1, are a company, we have hard time to improve performance when invoking service first time. First time is always troublesome to us because it takes a long time. Second, third was only a few seconds, but only first time for the last time about 10 seconds. So I have a hard time. So if possible, could you give me some ideas to reduce, improve the performance when invoking the service first time?
So you are talking about the client side, right? Client side proxy, right? Yeah, as I think I already mentioned in the slide that the major issue is when you creating the client side proxy, you need to read the whistle. And very likely, you can look at your generated code to see if the whistle is remote. Remote means that the whistle is in the annotation, like if the annotation say the whistle location is HTTP something, that means it's remote. So a workaround for this is that you can use the browser to store that whistle as a local file, and then use XML catalog to redirect the reading to the local file. However, that still means you need to read the file. It doesn't really solve all the problem. That is the first issue. The second issue, in addition to reading the whistle, is that the client proxy usually need to create something like a JSP context. And JSP context creation is expensive. We have been looking in the first issue by not to read the whistle. But there are a lot of debates on that because some people think web service always need to read the whistle because they have some fancy thing, policy that could be dynamically changed on the whistle. They don't, those guys doesn't agree with us that all the information, we can preserve those metadata on the proxy generated code. If we can do that, we can remove the first item. But the second item is that creating the JSP context, that is the non-issue. But if we can have all this removed or improved, the startup time will be faster. However, I would suggest you that you should cache the service object. And yes, it's difficult to improve the performance. But for the proxy generated from it, it should be fast. Yes, you can cache the proxy as well. But remember that the proxy is not very safe. So you probably want to put the proxy instance in, for example, object pool for that.
You mentioned, proxy is not guaranteed to be very safe.
Yes.
Take care of that in the specific.
So maybe before we close it, Justin, if you have any strong opinions on any of the things we just shown, or if you have any other ideas and something comes to your mind, then metro.java.net, either file an issue or send to the user forum, and we'll try to get that into consideration. So thank you very much for attending.